All right, let's talk about inputs and outputs. These are inputs and outputs to a computer. So on the left, I have the inputs. There's a pull-up resistor and a pull-down resistor. We'll get into the details here in a second. And on the right, I have output. This is a low side driver and a high side driver. It's important to understand the distinction between an input and an output. An input is gathering in information about the external environment. So outside of the PC or the computer, I'm getting information about a switch or a sensor. And I use either a pull-up resistor or a pull-down resistor to do that. On the output side of things, I'm turning something on or off. It's some type of a load, and the CPU or the computer is saying, turn this item on. So let's focus specifically on input for now. An input has two different types. An input can either be a switch or a sensor. An example of a switch might be a door switch or light switch. An example of a sensor might be a temperature sensor or a position sensor. A switch will either have an on or off position, and a sensor can have a very significant amount of range of positions. Think of the different ranges of temperatures that you might measure. So let's just focus on the switch for now. On the left, you'll see the two different types of ways that I can identify the position of a switch. For improved clarity, I've added a red dashed rectangular box. The box is to identify the computer itself. If we leave the computer outside of the red dashed box, those are the pins or the external pins, and they would be connected to an external switch somewhere. So the switch is not inside of the computer, it is outside. The only components that are inside the computer are the pull-up resistor and the pull-down resistor. The way that these electronic components work is very similar. However, one is using a 5-volt source and the other is using a ground. We can see that in this position that a pull-up resistor with an open switch will read 5 volts. The pull-down resistor with an open switch will read 0 volts. When we close the switch on a pull-up resistor, that then drops the voltage at the pull-up resistor and we read 0 volts. On the pull-down resistor, when we close the switch, we are dropping the voltage at the resistor. However, we're measuring the voltage prior to the resistor, so we have a change of 5 volts for a closed switch on a pull-down resistor. All right, let's switch over to outputs. So here we have a blue box that has a CPU in it and a transistor for both the low side driver and the high side driver. That represents the computer itself. Outside of the computer, I have two loads. In one example, I'm providing 5 volts to the load on the low side driver. And in the other example, the high side driver, I'm providing a ground to the load. The transistor that is internal to the computer is turned on by the CPU. So the CPU receives a signal, probably from a switch, and then the transistor is turned on or off. So let's walk through an example scenario. So I have an input. In this case, we'll call it the door switch. And so we're actually going to start with the door in the closed position, because when the door is closed, we want the light to not be on. Let's call the light just the interior light of the vehicle. All right, so my door is closed, so my switch is closed. The voltage sense for my pull-up resistor would then be 0 volts. This value would be stored in the CPU, and we would know that when I get a voltage value of 0 volts on this particular input, that is an indication that the door is closed. I would then need to transmit that information across the CPU to the output to tell that transistor to remain in the off position, opening the switch, which would then take away ground from the load. All right, let's see the steps that happen when we open the switch. So we've opened the switch, the door is in the open position, and that gives us a voltage sense value of 5 volts. Stored internal to the PCM is the data that indicates that when the voltage sense is in the 5 volt position, that indicates that the door is open. I would then transmit that data across the CPU and tell the CPU that the door is in the open position. The CPU would then respond by indicating that it understood that the door is in the open position. That would then tell the CPU to command the transistor to the on position, which in a sense is closing the switch, and then providing ground to the load, which would then illuminate the interior lights. So in summary, we have inputs and outputs going into the CPU or the computer. On the input side, we have pull-up resistors and pull-down resistors. By far the most common way to do an input is to utilize a pull-up resistor. That's the most common one that you will see. On the output side of things, we have either a low side driver or a high side driver. Don't get too caught up on the type of transistor that is utilized. In this example is just for simplicity. As I mentioned before, that it's actually a significantly more complicated process. Just remember that a low side driver provides ground and a high side driver provides power. The thing that you should take away from when we look at the input compared to the output is that they are electrically isolated, meaning that when I close that switch, there is a program that determines whether or not to turn on the light. At any point, I could go back into the programming and indicate that when the switch is in the closed position, I should turn on the light. That's just a program that is determining what voltage sense, what should I do when I receive a specific voltage sense. So when programmers are going back in and reflashing a vehicle, sometimes they are making just changes just like that. So hopefully this helped you with understanding inputs and outputs.